This is the second of a 4-part video series for your study of regression analysis, chapter 3 of AP Statistics. And in this video, we'll be speaking about the correlation coefficient. In part 1, you saw this template for how to describe a bivariate relationship when the relationship is linear. And so we were talking about making sure that we describe the direction, strength, and the form here is linear between these two variables. And you saw this part as evidenced by the correlation value of, and you see this variable r. And so we will talk about r, which is known as the correlation coefficient. Its real name is Pearson's rho, and you can do some study on that if you like, but it's not necessarily important in order to understand what's happening with this value. In general, the correlation coefficient measures the strength and direction of linear relationships between two quantitative variables. So these items that are bolded and underlined are important. Strength in terms of the value's closeness to 1 or -1, which we'll speak about in a few moments. Direction in terms of its sign, positive or negative. And again, notice that we can only describe the linear relationship and that the two variables have to be quantitative. There is a formula here. It looks really intimidating, but it's nothing more than taking those XY ordered pairs, standardizing them, changing them to z-scores, multiplying them together, adding them all up, and then dividing by n-1. And we'll have a simulation in class where I show you the significance of those products and how we arrive at the sign, S-I-G-N, for R. Here's some basic facts about the correlation coefficient. One, know that its value will be no less than -1 and no higher than +1. And so that gives us a range of values to work with. Anytime that value is positive, then that lets us know that we have a positive association between the two quantitative variables that we're studying. If the R value is negative, well, that means we have a negative association between those two variables. When R is close to 0, that tells us that we have a weak association. And again, keep in mind that this is talking in terms of the linear association. If R is really close to -1 or 1, then it means a strong association. -1 is not bad. It just means that we have a negative sloping line, or we have that inverse relationship of low x values, high y values, high x values, low y values. And lastly, R is strongly affected by outliers, and you should recognize that that is because we are standardizing these scores, which forces us to use the mean in terms of calculating the z-score. So if the mean is affected by outliers, then certainly any calculations based upon the mean will be affected by outliers as well. Let's take a look at some scatter plots and assign correlation values to them. These correlation values have been pre-calculated. I will only ask you to maybe match these up just so you get an idea of how the numbers quantify the relationship that we see in the closeness of the dots in the scatter plot to a line. So as we start on the top left, this relationship appears almost circular. It's difficult to tell if we're going up for a positive association or down for a negative association. So this quantifies actually as a correlation value of 0, which would be a weak linear relationship. Again, that doesn't mean there's no relationship at all, just the ability to define this relationship with a line is very difficult. On the top right, we have definitely taking some shape here with a negative relationship. And so this correlation value we would assign as a negative 0.3. Still weak, but some shape taking place in the negative direction. In the middle, on the left-hand side, we have a positive sloping relationship. We're moving up and to the right, but not lying very close to a given line. And so we would give this a correlation value of 0.5, which we would consider to be moderate. On the right-hand side in the middle, these dots are definitely closer than what we saw above and also what we saw to the left. So we would expect the magnitude to be higher, but because this is sloping in a negative direction, we expect the correlation value to be negative. Again, it gives us strength and direction. And so the value that we see here is a negative 0.7, which we would assign moderate to strong. Now as we move to the bottom right, bottom left, we'll see that these dots are lying definitely closer than the ones above that we've all looked at before. And so we would expect this number certainly to be higher than 0.7, but because of the positive trend, we expect R to be a positive number. And so we reveal that this is a correlation of 0.9. And we would think 0.9 would be really, really, really close together, but just remember that strong does not mean perfectly linear. And lastly, on the right hand side, these dots are much closer together than the ones that we saw on the left with 0.9. So we expect the magnitude of the R value to be much higher. In other words, the number will be higher than 0.9. But because this is a negative trend, we would expect R to carry a negative sign. And so we see that this has a correlation value of negative 0.99, which is very, very, very strong. And it's just about as good as we're going to get without making up data. These are just some cautions I want you to be aware of. We said before that association does not imply causation. Even if we have a correlation value of 1, this in no way indicates that the explanatory variable caused the response that we see. Remember that we can only justify causation through a well-designed, well-implemented experiment. Secondly, don't use the word correlation when you really mean association. And that's important in AP statistics. You may be able to get away with that on the outside world, so to speak, but we want to say that two variables are strongly associated as opposed to saying strongly correlated. And lastly, make sure that you go over the cautions about the correlation coefficient in your textbook, what happens with unit changes, categorical variables, and things like that. Those are important conceptual questions or conceptual ideas that you could be questioned about. Lastly, this slide just walks you through how to find the correlation coefficient on your calculator. It requires you to perform linear regression, which at this point, it's not a big deal that you don't know what that is. That's actually part 3 and also part 4 of the video series that we're doing for this unit. So this gives you some details on how to perform these steps in your calculator. So make sure that you practice that. I'm expecting that you will be able to do this because I'm giving you the directions now. So please make sure you practice this weekend in finding the correlation coefficient. And back to the example that we had before, if you were to key these in your calculator, you should already have them keyed in if you're watching the videos back to back. And practice finding the correlation coefficient in your calculator. You may want to pause the video while you do this, and I'll reveal the answer after you have keyed it in. Or you can just reveal the answer now and then check yourself after you key it in. And so you should have found a correlation value of 0.48, which we would consider to be on the weak side of moderate. So we would say like a moderate to weak relationship, linear relationship between these variables. And remember from the last video that we said there was some curvature in there, and so a linear model might be a little suspect, but we'll talk about that at a different time as well. And that's the end of part 2. Scatter plots and correlation go together. When we come to class on Monday, remember that I am assuming that you will have read and watched both of these videos, so you'll be ready to ask any questions that you have. Again, make sure that you fill out the feedback form so I'll know what information to prepare for you in terms of trying to answer your questions for Monday. And I will see you then. Have a great weekend.